In this section, we will be discussing rates of change and behavior of graphs. This corresponds to the OpenStax textbook, the college algebra textbook, section 3.3. So the first few, we're going to find the average rate of change of each function on the interval specified. The formula to find an average rate of change, this is just the change in the function values over the change in x. So let's see. You might see it as the change in f of x over the change of x. That means f of x1 minus f of x2 over x1 minus x2. I think in your book it might have switched the 2 in the 1 place, but it doesn't matter as long as they're lined up correctly. So as long as the 1s are the first value and the 2s are the second value, or vice versa. So let me just write it out. Alternatively, you could write f of x2 minus f of x1 over x2 minus x1. As long as your 2s are lined up and your 1s are lined up above each other, it doesn't matter which one comes first. Remember that the f of x values are really just your y values. So this is just another way to say kind of the slope, right? Because the slope of a line is the average rate of change. The difference here is you can do this for other functions besides just a linear equation. So the average rate of change can be used on different kinds of functions. Okay, so this first one, in order to use that formula, we have to know the x values and we have to know the f of x or the y values. So it's giving us an interval. So this is an interval. So this is not an xy, these are both x values. So this is an interval where x1 and x2 are given. So we want to know what y values will be associated with these. So in order to find those, we're just going to plug that in. So to find f of x1, we'll use -2, and we're going to plug that in. And we'll see that we get 5. This -2 squared is what I have to do first. So that will be a +4. And then that +4 times the -2 will give me a -8. So I subtract and I get -3. And then I want to do the same thing for the second x value. So let's say x2, I'll do that in blue. So f of 4 is equal to 5 minus 2 times 4 squared. So that'll be 5. 4 squared, I have to do that first, is 16. 16 times a -2 is -32. 5 minus 32 is -27. Okay, so now I have the x values that were given, and I also have the y values. So what I want to do now is use the formula. So the change in f of x over the change in x. Okay, so the f of x values were -27 minus a -3. Okay, so since I used the blue first, I need to use the blue x, so that would be 4 minus a -2. Okay, so again, x1, x2, this would be y1, and this would be y2, and that's because this was x1 and this was x2. Okay, so you have to make sure you go in the same order. All right, so now I know that if I have 2 negatives, this ends up just becoming plus, right? So I'm going to have -27 plus 3 over 4 plus 2, and that is -24 over 6, which is -4. This is the answer that I'm looking for here, -4. So the average rate of change over the specified interval is -4. So again, your goal is to find the y values or the f of x values based on the x values given. All right, so again, in this one, I have two x values. Remember, this is an interval. Now I need to find the associated function values. So to find to find y1, right, or f of x1, I'm going to use the 1. So I'll have 3 times 1 minus 4. So that's going to be 3 minus 4, which is negative 1. So this is y1. Let me put it here. That's x1. Okay. Now I want to do the same thing for the other point. So f of 5. So this is x2. Okay, I'm going to have 3 times 5 minus 4. So that's going to be 15 minus 4, which is 11. So that is y2, since this was x2. Now I just need to find the average rate of change. So the difference on the y values over the difference in the x values. So 11 minus a negative 1 over 5 minus 1. So again, this is the average rate of change, and I'm using y here, but remember that's f of x. You can put whichever one you want. 11 minus a negative 1 is 11 plus 1. So then we'll have 12 over 4, which is 3. So the average rate of change on this interval is 3. Okay, so just to note here, the average rate of change was 3. This is a linear equation. The slope is 3. That should always be the case. If you have, let me look at the last one. Nope, see, the last one was not a linear equation. It was a quadratic equation. But if you have a linear equation like this one, your average rate of change is just your slope, okay? All right, let's look at number 3. So number 3, again, these are x values, so x1, x2. Here I have an h, so I'm going to end up with some kind of expression, so keep that in mind. But you still work it out the same way. So g of x equals, and let me put in a 4 here. So g of 4 equals 2 times 4 squared minus 9. So we're going to do the exponent first. So 4 squared is 16 times 2 is 32. And then 32 minus 9 is 23. So since this was what I called x1, this is going to be y1. All right, now I want to do the x2, that's h. So g of h is equal to 2 times h squared minus 9. So this is going to be 2h squared minus 9. There's nothing else I can do here. So that entire expression is my y2. So here's x, whoops, not 1. Here's x2, so this is y2. All right, so now I'm going to do y2 minus y1. So 2h squared minus 9 minus 23 all over x2 minus x1. Okay, so the difference in y's over the difference in x's. Now I'm going to try to simplify as much as possible. So we'll have 2h squared minus 9 minus 23 over h minus 4. I can combine my two like terms here on the top. So that will be 2h squared minus 32 over h minus 4. And then I can try to factor the top. So a 2 can come out. So that'll give me h squared minus 16 over h minus 4. Okay, so now I'm going to have 2 h plus 4, h minus 4, because that is a difference of squares, over h minus 4. And now you can see that the h minus 4s will actually cancel out. So I will have 2 times h plus 4 left. So that is my average rate of change. So once you get to this step right here, don't forget to try to factor the numerator or denominator and then reduce if possible. Otherwise you won't get full credit because you didn't take it all the way and simplify it. Okay, so that's the average rate of change given an interval. The next thing you're going to be looking at is the difference quotient. So this formula right here, whoops, that is called the difference quotient. And you'll be using this a lot, and this will come back if you're taking calculus. You'll see it there. So what you want to do is you have to find different pieces. You have an f of x plus h, so that's one piece you have to find. You have an f of x, so that's another piece. And then h is just h, so you just leave it as h in the formula, okay? So notice the f of x, I already have that. That's given. So I already know what I'm going to use for f of x. It's this, okay? But I don't know f of x plus h, but I can find it. So that is my first goal, is to find f of x plus h. And I do that by plugging in x plus h everywhere there is an x in the given function. So now I need to distribute the 3. So I will have 3x plus 3h minus 2. Okay, there's no like terms there, so that's as far as I can go. So f of x plus h is this expression. Okay, so this red box is going to be plugged in here, and this blue box is going to be plugged in here. And then I'm going to simplify. All right, so I have 3x plus 3h minus 2, that was what was in red, minus what's in blue, 3x minus 2. Okay, all over h, which just came directly from the formula, the h, right? So it's red minus blue over h. And now I'm going to simplify this. So 3x plus 3h minus 2, distribute the negative, minus 3x plus 2 over h. All right, notice that I have a 3x and a negative 3x. Those are opposites, so they zero out. I have a negative 2 and a positive 2. Those are opposites, so they zero out. And all that I have left in the numerator is a 3h. On the bottom, I have an h. Since I now have h's on top and bottom, I can cancel those out. And my answer is just 3. So here is the difference quotient, 3. This seems kind of complicated, but if you work on these and do a few examples, I think you'll be okay. Just make sure your goal is to find f of x plus h first, and then just substitute that and the f of x into the formula. All right, so let's look at one more, or I have two more. All right, so this next one, we have f of x equals 4x cubed. So this is my blue, right? So this is my f of x. Next, my goal is to find f of x plus h. That's always where you start. You do that by plugging in x plus h in the x place. Okay, x plus h cubed. I'm going to have to do some scratch work here. That means x plus h times x plus h times x plus h. So what you want to do here is you're going to start with just 2 of them. So I'm just going to look at 2 of these and distribute those, and then I'll use the last one in a minute. So this is going to be x times x is x squared, x times h is xh, h times x is xh, and h times h is h squared. I'm going to combine these like terms. So I have x squared plus 2xh plus h squared. Okay, so that was the first 2. Now I have to multiply by this one. So I'm going to bring it down and multiply what I got by that one. So I have x squared times x is x cubed, right? This times this. X squared times h is x squared h. Now I have to do the 2xh. So 2xh times x is 2x squared h. And then 2xh times h is 2xh squared. Okay, h squared plus x is plus xh squared. I'm running out of room here. And then h squared plus h squared times h is h cubed. All right, so like terms. I have x squared h and another x squared h. So those are like. I have xh squared and xh squared. So those are like. So I have x cubed plus 3x squared h plus 2xh, it should be 3, plus 3xh squared plus h cubed. Okay, so that was a lot, right? So now I have 4 times what I just got. So x cubed plus 3x squared h plus 3xh squared plus h cubed. So now I have to distribute that 4 to all of that. So that will be 4x cubed plus 12x squared h plus 12xh squared plus h cubed. Oh, I forgot to distribute the 4 to that. 4h cubed. Okay. Now, all of that work was just getting the f of x plus h. So remember, I've got to now plug all of this in that formula. So this is the red. This is f of x plus h. All right, so the formula is f of x plus h, so the red, minus f of x, which is the blue, all over h. All right, so if I do that, I'm going to have 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed minus 4x cubed, okay, all over h. All right, so 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed minus 4x cubed all over h. So notice I have 4x cubed and negative 4x cubed, so those cancel out. And I'm left with 12x squared h plus 12xh squared plus 4h cubed all over h. And so now notice that every single term has an h, so I can divide that out. So that'll give me 12x squared plus 12xh plus 4h squared. That would be my difference quotient for number 5. So definitely a lot more work than the first one, right? Number 4 was a lot less work. Okay, let's look at number 6. So this is the same process. So first, I realize that I have my f of x. That's always given to me. Now I need to find my f of x plus h. That's what you always do first when you're doing the difference quotient. So everywhere you see an x, you've got to plug in x plus h. Okay, so now I know I'm going to have to multiply that out. So x plus h times x plus h. And actually we did that on the one right above this one. I erased it, but we did that just a minute ago. So I'm just going to put the answer down for that. So that was x squared plus 2xh plus h squared. Then we're going to distribute the negative 3, so we'll have negative 3x minus 3h plus 1. Okay. Now we want to distribute the 2, so we're going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. All right, I'm going to look through to see if I have any like terms, but I don't. So that is going to be my f of x plus h. So that is my red piece. Okay. And now I've got to use the formula. So I do f of x plus h minus f of x over h. So red minus blue over h. All right, so I'm going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared minus 3x plus 1 all over h. All right, so you're going to distribute this negative. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1, and then minus 2x squared plus 3x minus 1 all over h. So now I'm going to be looking for stuff to cancel. So I have 2x squared and negative 2x squared. I have negative 3x and positive 3x. And I have 1 and negative 1. Notice that each time everything that does not have an h has an opposite and is canceling out. All right, so then the last step, we're going to combine our like terms if we have any. If not, we're just going to write down what we have left. So we have 4xh plus 2h squared minus 3h. I think I got all the parts left. All over h. Everything here has an h, so if you divide out an h, you get 4x plus 2h minus 3 as your difference quotient. All right. The next thing you're going to see in this section is some graphing problems, and you're going to be asked to do several things. So for number 7, we are trying to find the average rate of change from x equals 1 to x equals 3. This is actually exactly the same thing we did in the first 3 problems. It's just presenting it to you in a different way. So if you look at x equals 1, that's here. And if you go up to the line, you see that the point on the graph associated with an x value of 1 is 5. So your ordered pair here is 1, 5. If you look at x equals 3, and you go to the graph, that's here, and the ordered pair for that is 3, 1. Now you have an x value and a y value. You have x1, y1, x2, y2, and you can just use the average rate of change formula, which is just like the slope formula. So your average rate of change is going to be y2 minus y1 over x2 minus x1. That's going to be negative 4 over 2, which is just negative 2. So that's my average rate of change from x is 1 to x is 3. So same thing as 1 through 3 earlier, just a different given information. All right, so here's another example, number 8. We're going to use the graph to estimate the intervals on which the function is increasing or decreasing, and then identify the local minimum and local maximum. So first, we want to talk about the increasing and decreasing. You read your graph from left to right. So if I start at the very left part of the graph, and I just move along the graph, you can see that's going down, right? So that's decreasing until I get right here at this bottom part. So it's decreasing from here all the way until here. When you're talking about increasing and decreasing, you're talking about x values over the x interval. So from x is negative infinity, because it goes to the left forever, and it goes until you get to here, which looks like it's about halfway between negative 1 and negative 2. So negative 1.5, it's decreasing. So your graph is decreasing from the x values negative infinity to negative 1/2. Then if you follow your graph, you can see that now from here, it starts going up. So this is increasing, and it keeps increasing until I get right here. And that looks like it's associated with an x value of 2. So now it's increasing, starting over here at the negative 1.5. And it keeps increasing until I get to the 2. Okay, now I'm going to pick up here at the 2, and I'm going to be decreasing. And it decreases, has an arrow on the end for the rest of the graph. So another decreasing interval is from 2 to infinity. So again, you're looking at x values. All of the values in these interval notation are representing x values. The other thing is when you're talking about increasing and decreasing, you always use parentheses. So it can't be increasing at one point. It's over an interval that you can be increasing or decreasing. So always use parentheses for increasing and decreasing every time. Okay, so that's increasing and decreasing. Read from left to right. If you're going down, it's decreasing. If you're going up, it's increasing. Finding the local minimum and local maximum is actually pretty easy. All that entails is looking at, a bottom value in a certain region. It's where a graph stops decreasing and turns around and starts increasing. So for example, down here, you can see it's a bottom, right? So that's going to be a local minimum. All right, it goes from decreasing to increasing. It changes direction at that point. Another place where it changes direction is right here at the top where the x value is 2. This is a local maximum. Now it's not the maximum value ever reached because you have an arrow on the end. Just like the local minimum is not the absolute minimum. It's a local minimum and a local maximum because it changes direction around that point. Okay. Number 9. Use the graph to estimate the intervals on which the function is increasing or decreasing, and then find the value of the absolute minimum. Okay, so let's start on the left-hand side. So here's the leftmost value, which has an arrow, so it goes forever, but on the graph, here's where it starts. And you can see I'm going down, right? And it keeps decreasing until right here. So decreasing, and you're looking at x values from negative infinity until here, and the x value associated with that is 1. All right, now I'm going to start here, and I'm going to go this way, and I can see I'm increasing, and the graph continues forever to the right. So I'm increasing, beginning at this x value of 1, and I'm going to continue increasing until infinity. Okay, so in the last example, we talked about local maximum and local minimum. Right here, it changes from decreasing to increasing. So this is a local minimum. But this is also the very bottom value ever, right? There is no other value that gets lower than this. This is the bottom of the graph. So this is also called the absolute minimum. Notice we don't have an absolute maximum because it goes on forever. We can never reach infinity going up. So there is no absolute maximum value. There's only an absolute minimum value. The absolute minimum is associated with the y value. So the absolute minimum value is a -3. All right, the last one, we have an application problem. So a driver of a car stopped at a gas station to fill up his gas tank. He looked at his watch and the time read exactly 3:40. At this time, he started pumping the gas into the tank, and at exactly 3:44, the tank was full and he noticed that he had pumped 10 gallons. What's the average rate of flow of gasoline into the tank? So the average rate of flow. So you want to know gallons per minute, right? How many gallons per minute is flowing? So if you're going to do gallons per minute, you can set up your fraction like that. So you're going to find the average rate of change. That's what the average rate of flow is. So you're going to find the difference in gallons from start to finish and the difference in minutes. Well, if he started out empty and he pumped 10 gallons, the difference is 10 minus 0, so 10. The minutes, he started at 3:40 and ended at 3:44, so that would be 4 minutes that have elapsed. So 10 over 4, and you divide that and you get 2.5. That would be 2.5 gallons per minute. So that would be the average rate of flow for this example.